Hey everyone, welcome to part 2 of my robot arm build. So in the last video you saw me make this lovely piece of engineering here, which is the base and the rotating sort of shoulder joint unit. So in this video we're going to be taking a look at the whole lower arm assembly. Naming convention gets weird because it's an arm that's sort of upside down to a normal arm. I'm gonna call it the lower arm, which would be for a human like the shoulder to the upper arm piece. So I've already printed this little piece here. So this is going to be the main kind of pivot joint for the lower arm. So I'm going to throw this together. Stick it on the base unit, show you how that goes together, and then from there the next main part that has to be done is I have to actually design the arm itself. So I have a rough idea of how it's going to work, but there's some design work that I have to do, some problems that I need to solve up front before I go and print it out. So I'm going to put this together, and yeah, then we'll talk a little bit more about my proposal, what I'm planning to do for the rest of the arm piece. So there we have it. That's basically the shoulder pivot piece put in place. So you can rotate around this base unit, and then along this steel shaft is where the arm will actually pivot. So essentially the plan is that there'll be the arm will come off like there. There'll be two fork bits that come out with bearings also pressed into them to fit in these gaps. And then the arm will be able to rotate on those. The way I'll transfer power is this flange on the far side. So we have one flange here, which is screwed straight onto one of these round servo horns for the servo. So then the arm will have a little boss that will come out, and then I can screw through here to be able to transfer the power to the arm. And with all the bearings in place, it should pivot nicely. So the only thing that I need to figure out up front, because I could just design this whole section and just print the arm just to test to make sure that actually works, but I figure I might as well try and figure out the elbow joint while I'm at it, which will be up here somewhere. So the difficulty with that is that, so not only do I have to figure out this coupling mechanism, I also have to figure out a coupling mechanism that's going to work up there, so that will then be able to actuate the upper arm, your forearm piece. So then I'll have the same problem actually when I go to design the forearm piece. I'll have to be able to have it coupled with the elbow, and then I'll also have to design like the wrist joint as well, where the end effector will go. So there's a lot of kind of chicken and egg pieces, but my general design approach when I do a lot of these things that have multiple pieces is I start with the basic parts and I start to kind of build it up. I could just go and try and design and model the entire thing out in CAD from scratch, but in my experience, whenever I do that, I'll make some mistake somewhere, or I'll make some assumption about exactly how something's going to fit together, and then it'll be a lot of wasted effort if I have to go back and redesign it if I discover that one of the intermediary pieces doesn't really work the way that I was kind of had it modeled to work. Maybe I'm not a good engineer, or maybe I need to sharpen up on my CAD skills, but anyway, that's just kind of my approach and the way that I sort of build stuff iteratively. So yeah, that's where we're at now. So I'm going to go off and I'm going to design the arm piece, then I'm going to print it, and then I'm going to put it together, and hopefully it'll work. So the only other thing actually that I want to talk about, which I'll talk about a little bit later, is basically the software and the hardware that I'm going to use to control these servos. So that's the other thing I haven't really looked at yet. I know it should work, everything I've thought through. I just need to go off and mess with it and make it work. So we'll talk about that a little bit later on as well. Okay, I've been playing around with some CAD, and I think I've made something that is a little bit crazy looking. So this is the am I going to get this name right? This is the lower arm. Yes, the lower arm. So yeah, it's a simple enough, straightforward enough piece. It's gonna has some mounting points the same as the base piece, with bearings can fit into. Same on top. On the bottom here, you can see this little flange bit, and that's basically the boss is basically to mount onto the flange, which will transmit power from the servo, which is mounted here to the drive shaft. So then the only other kind of crazy part is this piece up here. So the purpose of this bit is basically that's where another servo will be mounted, with the same kind of flange arrangement, with a shaft going through here, and then the other arm, the next arm, the upper arm, will have a piece like this at the bottom that will fit in here. The shaft will go through the lot, and then there'll be another boss on that end that will interface with the flange on the far end of the drive shaft, which will be able to drive then the upper arm. So I'm not really certain exactly what orientation I'm going to print this in yet. Probably something on its face like that, maybe. Yeah, something like that. That'll probably print okay. So yeah, I'm going to slice this up, get it printed, and then test it out on the machine for its fit. Okay, so we printed out the arm piece that you saw, and it's a little bit shaky. I got using some new filament, and it's not really behaving very well, so I need to mess around with some of the tuning on my printer, but it is a functional print. It's just not a very pretty print. So yeah, like it is, the dimensions all worked out pretty much the way I wanted them to. The only piece that didn't really print very well is this boss. There's a little bit of peeling up there from the bottom as it printed like that. So it was missing some build plate adhesion there, so I printed it with none. So yeah, I might address that in the design if I can. Might kind of square it off with it to give it some more contact area. But yeah, it is working. It worked out pretty well. But thanks to the magic of editing, I pulled a little bit of a sneaky on you. And this actually isn't the first one that I printed. So when we were discussing, when I was discussing in the last section just about how the joints were going to work for this, I was saying that I had to do some problem solving to figure out exactly how it was going to transmit the power and stuff, and that then I'd also have to redo that problem solving for the upper arm part, for where it's going to be the wrist joint. And then it dawned on me that I'd already solved the problem, so why did I need to solve it again? And so I've already built one arm. So this is the lower part of the arm, which is all wired up here with a servo in place. As I realized that the power transfer mechanism here is going to be the exact same as the one down here. It's just going to be flipped around. So this is going to mount on something like that. It's also obviously backwards. But yeah, that's it. So that'll work like that. This servo works like that. And that's it. So that's basically the whole arm pretty much finished, which is pretty cool. So the next thing I have to do then is I just need to assemble this. I need to put the pin in here, which I have already made. So I need to put the pin in, press the bearings into this, mount the servo on it, and then we essentially have the main axis of the arm pretty much all done. And because of the way this will work, is the way that the servo is already mounted onto it, that's going to be the actuation for the wrist sorted. So the only mechanical part that I have left to manufacture is the actual hand bit itself, and how that grabber is going to work. So I'll figure that out. I'll probably leave that to the next video to solve that. But for now, I'm going to assemble all the parts for this. I'm going to put it together, and then I do have to go and work on the electronics a bit and make sure that I'm happy with how I'm going to control the servos and everything. So I'm going to do that. I'll show you guys a little bit about that. I'm going to talk a little bit about how I'm going to approach that. Yeah, that's it. Okay, we're going to talk a little bit about some of the electronics that I'm using for this project. Mainly the part we're going to be talking about is how I plan to drive all of these servos for the arm. So on my previous videos I've talked about how I drive separate motors. You can check them out if you have a look for the playlist on my channel for building the CNC machine that uses these DRV8825 stepper drivers. So I'm just using one of those to drive that guy. But the board that I'm using to drive the servos is a new board that I hadn't used before, and that's this little guy, which is a PCA9685 servo driver. So this little guy is really interesting. Like there's servo boards you can get that essentially they take a PWM pin from your microcontroller. You put the PWM pin to the servo controller board, and then the servo controller handles the current requirements and stuff for your servo. So you're not trying to draw the current required from your power system or everything that you have for your microcontroller. You're actually using separate power to drive them. So like this would be common if you were to plug this into your computer, you are USB, and then you had your servo wired up to the same power supply. You'd essentially be trying to draw all of that power from, say, a 5-volt rail on this, which is actually coming from your USB, which isn't really a good idea. Or even worse, you could be, pulling 5 volts directly from the microcontroller, which you also don't want to do. So yeah, that's one type you can have. So for example, if you had then 4 or more servos, you'd have to drive each of them with one of those, which each one would then require, say, a PWM pin on your microcontroller. So if you're using a large microcontroller, that might not be an issue, especially if you're only, say, using a handful of servos. But if you're using a bunch of servos and you're using a small microcontroller that doesn't have very many PWMs, that's going to cause you an issue. So that's where this little guy comes in. This can drive 16 servos at once. You can supply it with its own power to drive the servos. And all it takes is 2 pins from your microcontroller, because it will communicate over serial with the I2C. So that's pretty amazing. You address it over serial, and then you can control 16 servos all at once, basically, with this one little board, which is pretty cool. So in my case, it's a little overkill for what I need, but it just so happens that this is a 16 channel one that I have. I think I will end up with 4 servos that I need to drive. But yeah, that's about it for that. It's really cool. I'm very happy with it. It seems to work pretty well. So with that said, then I'll give a little demo of what I have set up so far, which is really basic. Basically, on my circuit board, I have a little linear potentiometer here, which I have set up with some software on the Arduino to map it to a set of values, which will allow me to move just this lower part of the arm through a range of motion that I've predefined. So yeah, let's plug it in and I'll show you how it works. So that's going to its set point, which should be about the center point for the axis on the thing, on the servo. Okay, and then let's move back to, now we're reading the position from the potentiometer. If I spin the potentiometer, yay, I get movement. It's a little bit shaky. Because the potentiometer actually has a very large sweep, but of course it still can only read from 0 to 1023. So as you sweep the potentiometer, even if you sweep it smoothly, you're still getting some quantization in there, which isn't ideal. I also haven't done any there's a small filter that's added in place, but yeah, it works. If I spin faster, it moves a bit faster. It's a little shaky, but definitely moves. That's the important part, which is pretty cool. There's like quite a steep overhang that it's at. It's holding its position pretty well there. So these are 10 kilogram servos. Now the only thing, like, that sounds like a lot, but then as you start to put weight out on the ends of these things as they hang, that leverage really adds up quite quickly. So as I go through this, I'm gonna have to start setting limits and stuff for what what kind of angles the final arm can actually go out to, because it might not be able to actually support its own weight. So that remains to be seen exactly how much, but so far it does pretty well. Seems to support its own weight pretty well. So yeah, that's about it really. I think that's pretty much it for this video. The next things to do are, geez, what am I gonna do next? Everything. Loads of stuff still left to do. So I haven't built the end effector, so I need to build that, which will again use the same sort of coupling mechanism as here to mount onto here, which will just be the wrist joint, and then I have to figure out how to do the grabber. Basically I think I'm just going to go with a basic claw, maybe some elastic bands will keep it, and then you'll open it up with the servo and then it'll close under its own tension or something like that. Haven't designed it yet, so I have to design that and implement that. Then I have to, and then the other big task is I need to get rid of all this spaghetti wiring, which is, yeah, this is kind of, it is bumming me out a little bit. So I need to basically redo all this onto, I'm probably going to do it onto just some proto board, and then I also need to come up with a nice way of controlling it. So obviously this single potentiometer to move the angle, not great. I'd want some better interface so that I can move around the joints a little better. So I think the first thing that I'm going to do is figure out a way of maybe getting some little joysticks where I can individually just control each joint on its own, and then I'll probably go a little bit further and implement something like an inverse kinematic model where I can use the joysticks to set the desired X and Y coordinates, say in this space of the end effector, and then it can figure out where it needs to set all the angles at to achieve that position. And then yeah, the base one is pretty simple. That'll probably always just remain dumb, that I could just move a stick and it'll just revolve to whatever position I set it at. So yeah, I think that's it for now. I hope you guys enjoyed watching this video. Hope you learned something. Hope you found it interesting. Don't forget to like, subscribe, share with your friends, and if you'd like to help support the work that I'm doing, you can find a link in the description to my Patreon. And as always, thanks for watching, guys.